Are you familiar with union queries? Do you know what this is about? If not, this video is for you. Hi, I'm Philip from codekabinett.com, and today I'm going to talk about union queries in Access and in SQL in general. If you are experienced and if you know union queries very well, there's probably not much new I'm going to tell you today. But if you never heard about union queries or only have a rough idea what union queries are about, then this video is for you. So let's start. You all know the join operator, and the join operator kind of adds one table to the other side by side. Let's look at these two tables, and I join this table to this table, and then they are side by side next to another, and you will have additional columns from all the additional tables. Now, if you use a union operator, then it will be quite different and the tables will be added this way, one on top of the other. That's basically what the union operator is about. So, let's look at this in more detail in code. So this is the Northwind Traders database, and we assume we are a little business doing mail order, delicatessen mailings and earn money by shipping stuff to our customers. So we want to create a mailing to our customers and also to a lot of prospects from an address list we bought somewhere. So I will quickly create a query to show you our existing customer database. So this is a couple of fields, and I'm deliberately doing this in a query because we are going to need that in a minute anyway. So that is just a normal select query, and I selected crosstab accidentally. That's not what I wanted, just a plain select query. These are our customers, and notice there are only 30 customers in here in our customer database. Now we do basically the same thing again and drag in a table of prospects. This is, please note here, this is a link table. We are not allowed to mix that with our data, so we need to keep that separate, but we want to use the data, to combine the data for a single one-time mailing. So we need the prospect data combined with our customer data. So here we go. These are the prospects from all over the world, and you see that are 30,000 records. So two simple select queries, and now let's get to the union query. And I switch my first select query to SQL. And it's not really important that you actually see the details here. So I copy this, and now there is the union button here, and I click the union button, and what's happening here is pretty much rubbish because I was switching my SQL view to a SQL view, and I don't see any point why Access removes my existing SQL, but I copied it into the clipboard and can put it in here. Now I go back to the other query with my prospects, switch that to SQL view as well and copy that, and I'm not going to need that anymore. And I go in here, paste my prospect SQL, and what I need to do now is just add one operator to convert this to a union query. And the operator is union. And this will raise an error, but that is very common, so I deliberately execute it. It says the number of columns in the two selected tables are not equal, they don't match. And of course, if we want to add one table on top of the other, then the structure of the tables needs to be identical, at least the number of columns. So we get rid of the state column here, because that is probably the one that we don't need, and the company column as well. So, and now we run this, and now you see these are 30,038 records, so it's the prospects and our customers combined. Well, let's just switch pace a little bit. I created a small tool. This is a query editor I'm going to use for most of the remaining video. And I'm going to copy and paste in another union query I prepared here. And this is just, well, it's nothing special here. Just to make that sure, that this small utility is not a genius development tool. It doesn't do anything special. It's just here to show you how things work. To show you, like, when I run this query and I've got a keyword shortcut. Okay, I've got the same error as well. That's the company. We'll take that out for a second. And I run it again. And always, if you see the query screen flashing in green for a moment, then I execute the query. I do it with the keyboard shortcut, so you don't see my mouse move. But if you see the green flashing, then I execute the query. And now I've got the results down here as well, and we can get rid of the ribbon, so we've got more screen real estate here. And I can also use multiple queries at once, and now I run this, and now I can also present this nicely side by side, and this salmonish color in the result list, that shows this result list belongs to the query that you see here. If I switch back to query 1, then the salmonish color will also switch to window 1 in the results. That just as a tiny explanation on the side. And now we go in here, and yeah, I think the first important thing is if we put this here, you notice the first important thing about union queries. The query contains already just a lot of data, but the column headers are derived from the first SQL statement. You see, the second SQL statement, it uses fields with basically the same content, but the field names are different. And you see it's last blank name, or no, it's rather first blank name and last blank name, and then address, and this one is the zip / postal code and country / region. So it's clearly this line of field statements that defines our output fields. Now, if we want to add some filters, and I already did this here, I just want to send to the owner, the business owners of our customers, our mailing, then we need to filter this in each of the query statements. And also, we don't want to waste tons of money on international mailings, so we limit our prospects to people from the United States. And this country field belongs to this table, obviously, and the job title field only exists in our customers. So the where condition always needs to be attached to the select statement where it's coming from, and that it is supposed to filter. On the other hand, the order by clause is added only once, because the order by is sorting the whole query, and it's using the field names from the first query. So these are pretty important points here. And if we want to include fields that are only in one table, like our company name. We've got a company name for our customers, but not for our prospects. If I run that, I get the error you saw earlier because the column count does not match. But what we can do easily, we can just add in basically a blank column by just adding a null constant here. We could also do like two quotes here to indicate a empty string. That doesn't make much difference, but you need to, when you process the query results, you need to be aware what kind of constant you use there in the column output list. So, and we can also match columns of different types. So I add in another column, it's estimated customer lifetime value, and that is of course a currency value, and we don't have that value for our new hopefully new customers from the prospect list. And we want to make just a rough guess. We think we make 5,000 euro or US dollar, whatever you like, with each of the new customers. It's just a rough estimate. And now we run this query. And if I drag this over here, you see the 5,000 was taken from the constant I entered here. And I just entered an integer number. But if we scroll down, and you see it's already displayed with decimal digits. And my regional settings are the comma for decimal digits. If you are in the United States, you would see a dot there. So when we scroll right to the bottom, and now you see these are values of our actual customers, and you see there are also fractional numbers displayed like this 0.01 euro of lifetime customer value. It's probably not a good customer, but it's just a good thing for demonstration here. So I use the currency data type in one data set and the integer, the 5,000 hard-coded value, in the other data set. And then in the union query, that was automatically transformed to a currency value, because that is the least common denominator here. That's the best value to display that all. The 5,000 can be easily displayed as a currency, but the currency is required to display these small values you see here. So if I don't have a value in my first select statement, because that can always happen that you have some values in one select statement and they are missing in the other select statement, then you can of course add null, but that can mess up the data types. If I run this, you just see here there's just a weird sign here, because the null value does not even kind of convey any data type. So I don't know what Access assumed there. Maybe text, maybe binary, probably binary. And then it tried to merge the 5,000 into a binary column, and then out comes this. So, but what you can do is kind of add a number here. Then it would kind of display the number, of course, but it's not a currency. But what you can do, you can convert data. The ccur function converts the value to currency. And if I run this now, you see these values are again displayed as currency values. So you can use the data type conversion functions to force the data type in your result list. Of course, this only works if you have a value that can be converted to the desired data type. It wouldn't work if I enter something like ABC. That would just raise a type conversion error or data type mismatch in criteria. So, what's next? I've got a little query here. And I paste it here and run it right away. And now this shows only the city names starting with the letter G. And now, if you don't know the data set, you might say, yeah, that looks fine to me. But let's just copy over just one half of this statement. Get rid of this, put it in here. And now see this side by side, and we sort it alphabetically, so you will spot the problem right away. We have only one person in Geelong, whatever that is. And on the left side in our union query, we had one person or one record with Grand Falls, but there are two in the result set. And this is only the prospects data table. So in our customers, there could be even more. And the same for Green Bay. There's only one record here and 3 records on the other side. So this is something you always need to keep in mind. The union query here always works like the select distinct operator. It will eliminate duplicate records. And you can, of course, add in another keyword, and it's union all. And that is quite the same way as you would write a select distinct and then get rid of the distinct, then you would see duplicate values. And the union all does the same here. And now you see, now we've got all the values we expected in the data set. Okay, let's get rid of these 2 result sets and look at another potential problem. I paste in another query here, and this has a group by clause in each of the select statements. If I could, of course, get rid of one of these, but then it's kind of complaining. Well, I could also get rid of this one, of the aggregate function, then it would work, and it would kind of display records from from the first select statement, and it would display aggregated records from the second. But you always need to keep in mind that this also will trigger the removal of duplicates. If I run this, you see, once again, we have got, let's sort this. We've got duplicates here because, no, excuse me, I selected the wrong records. We have duplicates here because the number, the count of records is different for both records. So we have the city Green Bay twice in our result set. And the count indicates on the one side there were 3 records and on the other side there were 1. Oh, and I forgot something, but I'll go back to that in a second. So, of course, this is not a wrong result, but you need to be aware of that because the elimination of duplicates is also happening here. Now, we've got 10 of 10 records here. Now I added the union all and execute this once again. And now we have got 11 records because there was one city, Grand Island, that is once in the first data set and once in the second data set. So it will be eliminated in the final set. The duplicate will be eliminated. And even if you would kind of calculate the sum of the counts to get the total value, it would be wrong. So you need to be aware of that if you use aggregation and grouping in these kind of queries. Just be careful that you don't get wrong results there. So, and I forgot one thing, and that is something that's pretty helpful, and I go back to my previous query here, and I just get rid of the company name and just run this. And now we've got lots and lots of addresses in here, and it's nearly impossible to see, is the address I see here, is that a customer or is that a prospect? Because I don't know which one is which. I don't know each customer by name. But we can add a constant to each of the record sets here. I call this field C for customer as source. And then I add a P in here for prospect. And now I run this query, and it's complaining about, oh, I missed a comma here. So I run this query, and now you see here's the source column, and there it is switching. The first couple of records are C, customer records, and the other records are P for prospect records. So that is an option to distinguish the results, to distinguish the source of the results if you are just processing them. So that are the basics covered, I'd say. Let's do a very quick recap here. So the first select statement defines the output column names. An order by clause can be added only once, and it needs to be the last clause of the whole query. And it uses the column names from the first column. The where condition or multiple where conditions need to be added to their respective select statement where you want to apply the condition. Data types will be cast down to the common denominator, and if there is no real common denominator, like you combine a number with a date or anything with a text value, then it will be text, of course. And with text, there's something special I didn't show you, but I mention it here. Long text will be truncated to the first 255 characters in a union query. And always, and I move aside that you can see that, always keep in mind that union display uses a distinct operation on the data there. That is the error that I most frequently make with union queries. Now let's look at some of the limitations of union queries. Union queries are always read-only. You cannot write to them. That is for the reason that the database cannot say for sure, where is this record coming from? Can I write to it? It could be aggregated, but even if you use union all, union queries will always be read-only. And if you use union queries in your application business logic workflow, this is usually not a good idea because you need additional application logic to identify which table does contain the actual record that is displayed here if you want to update it or delete it or want to do any write operation. So be careful there. And in general, union queries usually have slower performance than normal queries. That's basically due to the fact that the union query needs to read two tables, or maybe one table twice, or 3, 4, 5 tables, because you can kind of concatenate an indefinite number of union queries one after the other. So there are slight performance problems. Also, with a normal union, the results, the duplicate in the results needs to be eliminated. So this will also slow down the query. So I wouldn't use them for general purpose queries. So some use cases. Basically, in our scenario, what we just did, we combined multiple tables for a data import or a data processing stuff. The same applies to reporting, where it sometimes is required that you kind of add different types of data like categories and the items belonging to the categories that you need to combine them in one data set for whatever reason. That is basically the most often used scenario for me, where I use union queries in practice. That's for reporting purposes. You can use union to add an all line to selections, and I will show that in a second. And finally, you could use that to kind of combine archive data with live data. Like you have a really huge customer database, but some of the customers haven't ordered for years, and you will want to keep them for documentation purposes, or maybe they come back and order again in the next couple of years, but you want to remove them from your active data set and put them in a separate archive database, especially if you are near the 2 GB file size limit of Access. And that is basically the only sane reason to do that, because I would rather not archive data that is still kind of integrated into the application. Usually if you archive data, it should be kind of shipped off to a backup drive and not be in the direct process of the application. But if you have to do this, particularly for space reasons, then you can use union queries to display data from the live dataset and the archive dataset. But I would definitely create a special function in your special feature in your application to view this data combined. In the normal of business workflow of your application, you should always focus only on the core data set for performance reason and for easier programming and business workflow in your application. So I had just mentioned the show all thing, and I show you what this is about. Here is a sales report dialog, and I hope I didn't mess it up. So I will use this sample. That is not the best one. Let's go to product. And we can select lots of products for our report, and then I can open the report and it's filtered. And the problem with that is what I see users struggling with sometimes. They selected a value and then they said, oh I rather want to see all of the values. I don't want to make a selection. And of course, you as a developer know, okay, we just can hit the backspace key to delete that and then run the report and we will see all customers. But some users really struggle there. So you think, okay, we are being nice to our users and we'll do what I did here already, but we'll do that for the products. Now hide that above to not distract you. We will of course use a union query, and then we will say select distinct, and then we say null. That is basically the value column here, and then we add an all as the display name. And of course we need to say from products as the table name. And now I save this, and this is the Northwind database. This is nothing I deliberately created here. That is built into the Northwind database, and it's quite clever actually. They put their select statements for the reports in a table. That's why I'm editing this table here. So I don't need to change anything in the design of that form. I just can now open the same dialog again. And if I now drop down the list of products, I've got this all entry in here. And if I select one and the user and say, oh, I rather want to see all, I click on this and it removes the entry, because the null value in the value column, it cannot really be stored and identified, so it removes the value. But that is what we intended here. So that's basically the perfect solution for the problem at hand. So yeah, I think we are at the end of this video. So union queries are a powerful tool to solve particular problems. Don't use them for general purpose stuff in your application that you say, oh, I can use a union to put apples and pears into one pot, and don't do that. Sometimes I see people, yeah, we can do that to create one sales table per year. Then we can join them by union and display them. Don't do that. Don't use union to cover up or even encourage or start with crappy database design. That's not what it's meant for. It's a very special operator for special tasks, and you shouldn't use it as a general purpose tool. So with this word of warning, let's wrap it up for today. Thank you very much for watching. I hope you enjoyed the video, and I hope I see you next time.